Okay, class. So we continue, okay, with our chapter 4, okay, on part B. Okay, so still in frequency response, but on series resonance. Okay, so in series resonance, okay, so it said that it is occurred, okay, when any system has a complex conjugate pair or poles, okay, so or it can act, okay, at which, okay, the circuit, okay, has at least one inductor or one capacitor. Okay, so the definition, okay, when the resonance is the condition, okay, when the RLC circuit, okay, which the capacitive coaxial and the inductive reactance or XL, they are equal in magnitude, okay, which resulting in the circuit to a purely resistive impedance of OR. Okay, so these resonance circuits, whether in series or parallel, okay, are useful for constructing filters. Okay, so their transfer function at this time can be highly frequency selective. Okay, and they are also used in many applications, okay, such as selecting the desired stations in radio or TV receiver. Okay, so we have series resonance circuit when your R, L, and C are connected in series. Okay, so we have the R, okay, J omega L, and 1 over J omega C in series. Okay, so the transfer function, okay, is the V divided by I, okay, which is equivalent to your total Z. Okay, the total series, okay, impedance is now equivalent to R plus J omega C plus 1 over 1 plus J omega L plus with 1 over J omega C. Okay, so the R, okay, plus with, which means the R plus with your imaginary part, okay, omega L minus 1 over J omega C, 1 over omega C. Okay, and then, okay, the resonance says that, okay, the imaginary part of the transfer function, okay, is equal to 0. Okay, so you, okay, you equal your imaginary part, okay, omega L minus with 1 over omega C equal to 0. Okay, and then the omega L now is equal to 1 over omega C. Okay, so omega squared, okay, you bring, okay, upwards the omega, so become omega squared, which equivalent to 1 over C. So finally, your omega naught, okay, omega naught is represent, okay, the frequency resonance is equivalent to 1 over square root of LC in radian per second. Okay, so it also called the resonant frequency, okay, the omega here. Okay, and then we know that the omega naught is equal to 2 pi f naught. Okay, and in hertz unit or f naught, okay, your resonant frequency, okay, is equivalent to 1 over 2 pi square root of LC. Okay, so this one in radian per second, and in F naught, the unit is in hertz. Okay, so we go to example 2 here. Okay, you have to calculate the resonant frequency of the circuits. Okay, with the given circuit here. Okay, so in first place, okay, you just find the equivalent, okay, frequency circuits. Okay, and then it give you, okay, J 0.1 omega, okay, for the inductance, okay, 1 over J 0.5 milli omega for the capacitance, okay, and 20 remain 20. Okay, so the total, okay, of the Z or the impedance in the total impedance here is, okay, 20, okay, 20 in parallel with 1 over J omega 0.5 milli omega. Okay, which this 1 over j.5 milli omega give you 2000 divided by j omega. Okay, for easy calculation. Okay, plus with this parallel equivalent impedance will be in series with your j 0.1 omega inductance here. Okay, and then you simplify the calculation. So you will get 20 times with your 2000 divided by j omega divided by 20 plus with 2000 divided by j omega. Right? This is how to get the parallel the equivalent parallel resistance here, or the equivalent parallel impedance here. Okay, then this side you can cancel 20 and then it will give you it will give you 1 plus 100 1 plus 100 divided by j omega. You make it small by divide all this term by 20. So you will get 2000 divided by j omega divided by 1 plus 100 over j omega. And then you go for cross multiplication at the denominator side here. So it will give you j omega plus with 100 divided by j omega, and then this one is the numerator side is still 2000 divided by j omega plus with j 0.1 omega. Okay, so from here, so you will go for the multiplication, the cross multiplication, 2000 times with your 100 minus j omega, this one you get, before I forget, so this is 2000 divided by 100 plus j omega, from the simplification, before this, so you times, the denominator, by the complement of it, so if you have the denominator 100 plus j omega, so the complement of it is 100 minus j omega. But you have also do the same multiplication with the numerator side. So finally you will get about 200,000 minus with j 200 omega divided by 10,000 plus with omega squared plus j 0.1. So remember that at resonance, the imaginary part of your z, sorry, it's not y, this is a z, imaginary part is equal to 0, and the omega is equal to omega naught, because we call or we label it as resonance frequency. The imaginary part only we equate to 0. The imaginary part is this part 2000 omega divided by the denominator is 10,000 10,000 plus with omega naught squared plus with don't forget this part is omega 1 omega. So we just replace the omega with omega naught, so we will get this term in terms of omega naught. So you bring so this one to the other side, and then you get 2000 omega naught divided by 10,000 plus omega naught squared is equivalent to 0.1 omega naught. And then you do the cross multiplication. Finally, you will get 1000 omega naught equivalent to 0.1 omega naught cube. And then you cancel. You will get omega naught squared is equivalent to 10,000 okay, 10,000. Thus, okay, the omega naught will give you 100 radian per, okay, second. Okay, the answer for the omega naught is 100 radian per second.